In our previous video, we had a little look at how pressure arises in our container full of gas particles. Now we're going to consider what happens when we change the temperature of the gas in our container. We're going to keep the volume the same, and we're also going to keep the mass the same. So what actually happens to my particles when I heat them up? They start to gain kinetic energy, so they move around quicker. A bit like your teacher after a coffee. Back to my container of gas particles. Because my gas particles are moving around faster, they are making more frequent collisions with the container walls. Actually, technically, it's only on average that the particle's kinetic energy is increasing. That means when I heat my gas, some of the gas particles start moving really, really quickly. Some move at the same pace that they were doing before, and some of them still move really slowly. I can relate to those ones. But their average kinetic energy as a collective has increased. Overall, there are more frequent collisions with the container wall. More frequent collisions means a higher force on the container walls, which means a higher pressure in the container. Now, what happens if I cool them down? They move slower. And if I cool them down again, they move even slower. And if I cool them down, you can see where I'm going with this. Eventually, they won't be moving at all. And that cold temperature where they've theoretically stopped moving is what we call absolute zero. I hate the cold, and that is really cold. It's minus 273 degrees Celsius, which is equal to 0 Kelvin. Kelvin is a new temperature scale, but it works in exactly the same way as degrees. It's just that 0 Kelvin starts at absolute zero, or minus 273 degrees. So if something has a temperature of 1 Kelvin, then it's minus 272 degrees. Let's do a quick example. At what temperature in Kelvin does water boil? Well, in degrees Celsius, water boils at 100 degrees Celsius. And to convert from Celsius to Kelvin, we add 273. So 100 degrees Celsius is 373 Kelvin. If I wanted to convert from Kelvin to degrees, then I'd minus 273. Time to look at some graphs. Pressure on our y-axis, temperature on our x-axis. The shape of a graph should be like this. As we've discussed, as our temperature of our box increases, the pressure increases due to those more frequent collisions with the container wall. Always remember your labels on your axes. Pressure is usually in pascals, but it could be kilopascals or atmospheres or another valid pressure unit. Temperature in this graph is in degrees Kelvin. I know that because I have zero pressure at 0 Kelvin when my particles have stopped moving. What would this graph look like if the temperature were in degrees Celsius? Now the pressure is 0 at minus 273 degrees. But the overall trend is still the same. As I increase my temperature, my pressure increases. In fact, this is how absolute zero was found, by extrapolating this graph backwards. Genius. Okay, let's have a look at some exam questions. This question is a 6 marker and it says, a container of gas is at room temperature, the gas is then heated, the volume of the container remains the same. By considering changes in velocities of the gas particles, explain how the temperature increase affects the average kinetic energy of the particles and the pressure the particles exert on the walls of the container. Let's first write down all the key points we're going to make about both of the bullet points above. Firstly, we might note that the temperature of the gas particles affects their speed. Then we're going to link that to the average kinetic energy of the particles, half mv squared. Then finally, you make the link that the higher speed, the higher the kinetic energy of the particles. Now it's time to look at the next bullet point, which was the pressure that the particles exert on the walls of the container. Now the higher kinetic energy of the particles leads to more frequent collisions with the container walls. These more frequent collisions lead to a larger force in the container. And because pressure is force over area, this leads to a larger pressure in your container.